Welcome to this presentation, Microservices on OpenShift. And I basically want to dive right in, kind of no long introduction or stuff. I want to show you an application. It's called the Cool Store. And let me just find it here. It's a retail application. It's a demo site, so it's nothing real. You have some products. You can, add something to a cart, and it's getting added. You can go to the you're here in the shopping cart. You guys don't see the whole screen. Okay. I have to resize a little bit as well, so that you see the whole thing. Something like this. It doesn't really matter so much. It's a classical retail site. We have some products, a user can log in, he can kind of buy something, he can kind of go through the whole process of checking out. Who has built a site similar to this? Yeah, many. I mean, many can associate with these type of applications. I kind of built multiple of these kind of sites, maybe not retail, but it was more in the search space. I was working for a long time for Yellow Pages, for online phone books. And I usually built them, like back in the days, as monolithic applications. One single WAR file, or if it was more complicated, one single EAR file. Does that kind of resonate with you? That's something you've done? Kind of monolith, big EAR file, Java EE. Let's have a look behind the scenes of this application. What we're seeing here is the OpenShift console, and what OpenShift is and how it works, I kind of get into a little bit later. Just stick here with me for a minute. What we are seeing here, all these boxes with the circles, that's basically one microservice, which I can control independently. And they are kind of like intuitively named. No? The cart microservice is probably the thing which you kind of put something to the cart and then go through the process of checking out. The catalog is the thing which kind of has all the product information. The gateway we kind of leave out. The inventory is maybe the thing which kind of tells me how many items of a certain product I have in store, and so on. So it's kind of this type of architecture. I also kind of, I can kind of scale or kind of shut down a microservice independently from the others. Who has built an application which kind of is more something like this, based on a microservice architecture and has it in production? Well, a few hands. So my question is, who thinks that this is a better approach compared to the monolithic approach? Who is for monolithic approach? Who is for microservice? Interesting. So my answer to this is, it depends. It depends on a lot of things, whether you should go microservice or not. And we're getting into the prerequisites of whether you can and should do something like this a little bit further on. Let me go back to the slides. The code for this kind of demo is a Cool Store microservice. You can find it on GitHub. You can check it out. You can kind of get yourself an OpenShift cluster for trying this out. And I want to kind of step back a little bit and kind of, what is a microservice? And I want to use a definition which comes from Martin Fowler and James Lewis, both working for ThoughtWorks. I think it's a great definition. And if you go to Martin's Fowler website /microservices, he has a whole aggregation of lists and resources on what microservices are, how to get into them, when not to get into them, and so on. It's a great place to start. But let's look at the definition. So a microservice architecture is a developing style where a single application is composed of a suite of small services. Think back to this OpenShift console. That was the cart, that was the inventory, and so on. And each of these services is running in its own process. And we've seen that as well. I could kind of shut this inventory service independently from the other things. What we're doing on OpenShift is a container orchestration framework. So we're running applications on Docker effectively. And that's, microservice style, architectural style, that's not new. It's just, it has a renaissance right now. People kind of rediscover it. And I think there are two main factors why it comes back. First of all, it's like running in its own process. If you have to manage this yourself kind of thing, if you kind of start from ground, that's hard. But with Docker in the picture, we have another level of abstraction which kind of makes this orchestration part and kind of running these independent microservices much, much easier. So that's Docker and things like OpenShift, Kubernetes, and Docker Swarm. They are enablers to kind of getting to this microservices world. The same thing, another enabler, in my opinion, is the cloud. Without the cloud, people would not kind of try this. In the cloud, we are nowadays able to provision machines or infrastructure within seconds, or minutes, maybe even seconds. If you're in a situation where provisioning takes days, you're not at a good place to start. Moving on, like these process services, they are communicating in a lightweight mechanism, for example, via REST. This is exactly what this demo, the Coolster application, did. All the services just talk REST to each other. They are built around business capabilities. It's a really odd echo, is it? Okay. Okay, hold on. Built around business capabilities. So this is not so much technical in nature, but one of the key challenges you're facing when you're going down the microservices road is it doesn't matter if you start from greenfield or from a monolith which you want to break up. You have to kind of find the themes along you want to build these microservices and along you want to kind of break up your business logic or your business domain. And this is not an easy thing. If you get this wrong, you kind of maybe end up with too many interconnections between services. So like this is a key part where you have to sit down, okay, I want to have really isolated and separated services around business capabilities. They should be independently deployable. Again, we've kind of just seen that. And it should be fully automated. There should not be kind of manual steps in between. You want to have an automated pipeline to kind of do these kind of things. And the other point is also a little bit more social, like bare minimum of central management. You can buy into this or not, but the idea is that every microservice should be able to do whatever it wants. So it means you can use a different language per microservice, you can use a different data store per microservice. How far you go down this road is debatable. I mean, if you're a Java shop and you allow everyone to kind of do whatever, and people throw in Node and all sorts of kind of things, you end up in a situation, can my people actually support this kind of thing? It might be great, and this one person who kind of wrote this service initially, he was really good in it, but if he leaves, I sit there and kind of have something which I can't maintain. Okay, so these are microservices. Martin Fowler has a great site, is a great place to look at this. Building Microservices by Sam Newman is another book I can recommend, also a great point to start. Sam Newman is also working for ThoughtWorks. I'm not working for ThoughtWorks, I'm working for Red Hat, so I'm not kind of promoting ThoughtWorks in any form here. They just tend to kind of have sometimes really good ideas. Another book which is not really directly related to microservices, Release It by Michael Newgard. It has some ideas about what kind of patterns you have to put into the microservices to have a stable architecture. So a lot of people will tell you, it's so good in the microservice world. The microservice is just so small. It's just a few lines of code, basically. True, but with going to microservices, things are not getting easier for you. It's not a free lunch. Martin Fowler calls this the microservices premium. Basically, what's happening is you're taking complexity from within the application. Like if you have a monolithic application, you have all these classes interacting within one big application. You're taking this complexity and making small single processes, but you're pushing complexity in the infrastructure, which you have to manage. Like services have to find each other, they have to talk to each other, there have to be some sort of resilience if something happens. So the complexity partly kind of goes into the infrastructure. Right, any questions? No? We can have some questions then in the end. Okay, so coming back to these ideas like what is better, the monolith or the microservices architecture. Microservices have a lot of advantages. They kind of scale better, potentially they give you the opportunity to combine services to create new products for a customer. Like if you have small services, you can kind of create a customer portal, you can create a sales portal, you can maybe easier build applications for the web and for the mobile. You gain flexibility and potentially the ability to scale very easily. But to kind of get to this point, you have to fulfill some prerequisites. Without them, you won't be as successful as the big play, like the Googles, the Facebooks, the Netflixes. They all have kind of meet these prerequisites, and they kind of are deeply vested in them because they know if we don't meet these ones, we are not kind of getting any or not enough value out of this microservices world. Let's go. The first prerequisite, rapid provisioning. You want to be able to kind of provision hardware or nodes or like something where you can run your applications in minutes, in seconds. I used to work for a company also for like many years back now, and we were doing this Yellow Pages thing, and we needed a bigger server for kind of our search index, which we had to fill out 5 forms, which had to go to the business, they had to approve it. The operations team ordered the machines. 3 weeks later, they would show up. So operation teams would provision them. They would come into a server room somewhere magically in the building, and then after 4 or 5 weeks, you would kind of get access. If you're in this kind of situation, you're not going to fly. And then you got more value out of trying to address that. Try go to OpenStack, try to kind of get your stuff into the cloud. You don't have to go microservices, you can deploy your monolith into the cloud. But be able to rapidly provision. Same thing with monitoring. You have to be able to monitor your system. If you have a single monolith and you maybe just run 1 or 2 instances, you can log into these machines and tail the log files. Yeah, no, okay. But think about the microservices world. You have, I don't know, 100 nodes, 200, 300, 400 microservices, who knows? You cannot log into each of these machines, and like each application runs in 10, 15 replicas. You need something that aggregates all the logs to you. Now that's where ELK and these kind of frameworks come in. So if you're not at this position where you at least are able to build these kind of things, you won't be able to manage it. And that's where like complexity lies in the infrastructure. And to kind of manage the infrastructure, you have to have monitoring on the physical level. You have to know what your machines are doing, if they are doing well, which loads are on the machines. And you have to know what your applications are doing and what load and stuff is on them. Rapid application deployment. In the definition, it was about this automated deployment pipeline. Now, if you build something, again, I've been there many times, you build the application and this EAR file or whatever gets handed over to someone, and it's his responsibility to get it onto the server. No good. You want to have some sort of pipeline or some sort of automated process to get it from the developer into production. So these first 3 are basically technically, you can kind of work technically on these kind of things and you can apply tools like OpenShift, which we will see in a second to help you. The next two things are more social or like team related. A DevOps culture helps. I mean, this is exactly like the situation I was in. Like we had these silos. There was a development team, there was an ops team, there was a business units. And I haven't mentioned yet the DBA. So I remember very well that the DBA had the golden key to the customer database. So if you, for some reason, wanted to change an index or something because you want, for whatever reason, you had to go through a whole procedure with the DBA just to kind of sort out these database things. You want to be in this DevOps culture where a team is kind of structured around a project or around one of these business capabilities. They develop the thing and they take it, if possible, all the way into production and are also responsible to maintain it in production. To which degree you have to get there is kind of debatable. It might be somewhere in between. Maybe there's, again, some people have the golden key to the production environment. But as close as possible, you want to come to the DevOps culture. And then the last thing, the team skills, I think that's also just important to mention. A lot of flexibility and a lot of things can be gained by microservices, but as I said, it's not a free lunch. And things are getting more complicated. We're adding layers of abstraction, like we're application, in a Docker container, in a container orchestration framework, in, you name it, in a build pipeline. These are all layers of abstraction which at some stage you have to understand. And at some stage things will break and you have to kind of unravel them to get to the bottom of the problem. And if you're in a team where you're struggling with controlling a monolithic application say a Java EE application where we have 15, 20 years of experience now how to do that. And we have established best practices. This is how you do unit testing. This is how you should go into a staging environment. This is how you do versioning. All these kind of things are established and nowadays quite easy to follow. In the container world and in the microservices world based on containers, which I'm trying to sell or kind of trying to introduce, these standards are not there yet. It's a little bit, you're like cutting edge there. So if you're in a team who are struggling with running something which is quite established, you're kind of getting in on shaky grounds if you're moving to microservices, because at some stage things will fail, and at some stage you will have to debug and dig deeper. Okay, but I hope I'm not turning off too much from the idea of microservices. What I want to show you now is DevOps culture and team skills. I can't help. I mean, that's something you have developed basically within your team. The first three things are really technical things, and they can be helped with the right tools. And that's where now OpenShift comes into the picture. OpenShift kind of fits quite nicely in these three kind of things. And with OpenShift as an architecture, you kind of, it's easier for you to kind of get these, meet these three prerequisites. I want to quickly talk about OpenShift, what it really is. Everyone knows containers, right? Everyone knows Docker, or we're all good. We not have to kind of reiterate on that. Running one single container on Docker is a breeze. I mean, like Docker run, done. But your application, especially in the microservices world, is not one single container. It's 10, 15, 20, I don't know how many Netflix runs, for example. So you need a framework which allows you to run these containers, or this distributed application on an infrastructure. You have multiple nodes, and you're running your application on that. And obviously, like Docker alone cannot do it. There's Docker Swarm, which is one alternative of an orchestration framework. And then there's Apache Mesos. And then the third option is Kubernetes / OpenShift and Kubernetes is pretty much the same thing. Red Hat took Kubernetes and made the enterprise version of it, so to say. That's OpenShift. But API, everything is basically the same. OpenShift is Kubernetes with a little bit of bells and whistles. That's it. And also, if you look at the industry clearly seems to adopt Kubernetes. Kubernetes is the most active GitHub project at the moment. There are heaps of people involved, partly commenting, partly implementing features. When it comes to orchestration frameworks, Kubernetes is basically making the race, I think, at the moment. Okay, to the architecture. You have some nodes, which are kind of your physical nodes you're running things on. And in the smallest addressable unit in OpenShift is something which is called a pod. It's not a container, a pod. And the pod is one or multiple containers. The idea is that on the pod, you want to be able to guarantee, this case here, that you can guarantee that on the same node, or both containers in a pod end up on the same node and running in the same environment. That's why pod is the smallest addressable unit. And then there's a master which controls everything. The master is maybe highly available, so that's why we have multiple masters here, but there's only one active one. And then there are a few components in this orchestration framework. There's the API server. That's the thing you're connecting to and kind of then making your administrative work, or you're kind of saying, I want Apache running 5 times in my cluster, these kind of things. There's the etc daemon, which is a distributed key value store, which makes sure the state of the cluster is persisted across the cluster. And for example, if the master fails, that another master can take over. So it's a scheduler. The scheduler is the thing, you're connecting to the API server and you're saying, I want my application running in 5 replicas in the cluster. And then the scheduler goes, this application is not there at all. I start 5 instances of the thing in the cluster. And then the replication controller kicks in. The replication controller is the thing which goes, I need 5 instances of this thing running, and it kind of monitors these instances, and one dies for some reason, the application crashes. Then the replication controller goes, only 4 instances left, I better go and restart another one, and we have 5 instances again. And the last component is a DNS component within the cluster itself. OpenShift or Kubernetes spans in DNS. So for each application or for each container you're starting, you get an abstraction called a service. That's an abstraction, doesn't exist, so to say, it's a name. and other services or other applications can look up other containers / applications by this name. The reason being is, if you have the same application kind of clustered, replicated 2 times, each of them gets its own IP. If you would have to refer to this via IP, and one node crashes, and it kind of, this one dies and kind of gets restarted here, IP changes, the whole cluster would fall down if you would have to refer to each other via IP. So there is this additional abstraction level of a service. I don't want to kind of go too deep into this anymore, kind of just the concept. It's a container orchestration framework. It's a cluster which allows you to run multiple Docker containers in an environment where kind of things can find each other, can talk to each other, and they can be kind of monitored. Now, kind of going back to the microservices, and now I want to show you a little bit how OpenShift and microservices can kind of interact with each other. And I'm doing this with, there's another demo application from Red Hat, from a group I'm working in. It's a Hello World microservices application. And this one is much simpler. It doesn't have a flashy GUI like this cool store thing we've seen. And the reason is, I just want to show you mechanics. Yeah, I want to show you the core thinking around microservices. And once you understand that, yeah, sure, you can kind of build other things around and build a UI on top and these kind of things. And the source code is also on GitHub in multiple repositories. Let's see. Right, so let's have a look at this application. It's somewhere here, I think, hope. Another interesting part, maybe, the first demo, the cool store demo I had on the web, it was a proper cluster which you could access. But this one, if you see, has a local IP. There's a tool I'm working on, it's called Minishift. And the idea of Minishift is to run on your host, on your local development machine, a virtual machine which runs OpenShift. So you're able to experience and develop against OpenShift offline, so that without having to kind of connect to a real cluster. And our vision is that developers use this locally for development. Then when they're happy with the code, they push it to somewhere, and then kick somewhere a pipeline in which does the actual production builds and stuff. So if you want to try OpenShift, a great way to do that is to download Minishift, and you kind of can try it on your machine. And it doesn't cost you anything. If you kind of provision it in the cloud, you basically have to pay for it. Okay, so what does this application do? It's very simple. It's a front end, which we're seeing here, and a bunch of backends written in different kind of technologies: Wildflame Swarm, Node.js, Vertex, Spring Boot. And each of them, the only thing they do is like you hit an endpoint and say return hello in different languages. Let me, so they return hello in different words. So if I refresh that, it says the first service says hola, the second bonjour, and the Spanish hola. No, must not, that's not Spanish. Spanish is the first one. And aloha Hawaiian. So I mean, this is it. And now we see already some architectural patterns here. So this is one architectural pattern you can design your application around. And that's, in this case, the browser is the client, and we have the microservices, and the browser directly calls the microservices and assembles the response to build whatever it needs to build. So there is another architectural side, which we are seeing here. And that's the gateway approach, where you're adding another component which also sits within your cluster. The browser or the client makes only one single call to the gateway, and the gateway then makes multiple calls to involved services, aggregates the response, and sends it back to the client. The advantage, of course, is like here you have less traffic over the internet. You have a gateway where you can control things like authentication and these kind of things. But of course, this one has also a single point of failure. If the gateway goes down, you're losing pretty much all services. It's a pro and con. I know that a lot of companies, especially if you build a website which kind of gradually degrades. So we can go back to this one. I hope I can show that quickly. If I reload, it's a cool store application now. So it's I hope it comes. For some reason, the rendering is really slow. Come on, come back. Here it is. No, here it is. Right, went. I should be more patient. This time I wait. No. Yeah, maybe. But remember when I was talking about it, I kind of just shut down the inventory service. Inventory unavailable. So this is one thing which you can achieve with microservices. Your application can degrade gradually. So depending on the business logic and what you want, you can, for example, say, if the inventory is not there, that's okay. You know, people can still order things, and we take the risk that maybe a certain item is not in store. But people can continue. Whereas in the monolithic world, if you would have a crash or an exception somewhere, your whole application is probably gone. And people would see a 500 or whatever HTTP error. So you have basically this possibility of degrading gradually. So this is, and then there's this third thing, which is service chaining, where you see that one service kind of calls another. And this kind of thing kind of leads me now back to quickly talk about something else, which is patterns, which you have to think about when you're going into this microservices world. As I said, complexity moves into the infrastructure. And one thing you have to keep in your mind is bulkheads. Everyone knows what a bulkhead is. So that's the thing in a ship, you know, like where if it kind of hits an iceberg and there's a hole in the hull, you kind of there are compartments where doors are closed and it kind of just fills one part of the ship and the ship doesn't sink. Without the bulkheads, if you couldn't close off sections of the boat, it would kind of fill up and would sink. And this is the same thinking you have to apply in your applications. Every single time you write a microservice, just within the microservice, but then when you think interacting with other microservices, you have to keep in your mind, if this service does not respond, what do I do? What's my fallback? And things like timeouts. Any call you make externally to another microservice, to an external provider, it needs to time out. Otherwise, if you're going back to this example, if this thing makes a call to this service here and there's no timeout, and this one stops responding for some reason, it kind of accepts calls, but it kind of never returns. All calls to this thing would be queue up, and this kind of backfires all the time. And after a while, your whole system goes down because you're not timing out. Another thing is fail fast. If there's an error, it's better to return to the user with an error instead of kind of internally trying to, where it makes sense, you can try to recover. Otherwise, fail fast. And the next one is also a nice one, circuit breakers. And that one I can demonstrate quickly. So I try to, and I'm hoping that I can also demonstrate now monitoring as well. A circuit breaker, it's basically this idea of a switch in your household. Like if there's not too much power drawn through your electrical system, a switch flicks and everything kind of turns off. And the idea is, if one of your services doesn't respond anymore, will it help if you kind of keep on hammering it? Probably not. The risk is the opposite. It kind of starts responding slowly. Maybe there would be a chance it recovers if you just let it be. But the user sits there and goes, reload. And each single reload is a request. So no good. So in this case, a circuit breaker comes in which goes like, hey, this service doesn't respond anymore. I kind of take it off and now it's a kind of business decision what you return. But I return some sort of default answer or an error or whatever. But I'm not kind of keep hammering this service while it's not responding. So let's see if we can make this happen here a little bit. On the right-hand side, I might have to reload here as well. So these are some of the components you have to think. And also like with OpenShift now, it's very easy. You can, within your infrastructure, you can deploy things like Hystrix, which comes from Netflix, which is like a circuit breaker. And it sits there in your infrastructure. And then other services you're going to write can use Hystrix to kind of do this circuit breaker thing. Come on, don't. Why do you not want to refresh? Let's see. Now I'm kind of hit by okay. I kind of leave what it should show. I don't know right now. You see the circuits for the different services are closed. I mean, it's okay to call them. And normally I would have expected now that the counts of requests are updated. But for some reason, this maybe if I go here, something happens. Here you see, yeah. So why does this one not refresh? I close this one. So if I go back here to service chaining, and if I kind of hit a few times refresh and quickly try to go back, you see like the count here is 11. So these are the requests coming in, and this is what monitoring means. At any time I can go to dashboard and I literally live see how many requests are coming in, if the responses are okay, if they're in a certain time interval, and so on. If I now go to the OpenShift console, and we are taking down the Ola service. Again, like here you see the mechanics of how, like, what OpenShift can do for you. Obviously, I'm driving it via a web interface. There is a command line tool which allows you to automate all this. This is kind of just the eye candy kind of thing, or like something which gives you a visual entry point. But for all the automation needs, you would use the OC command line tool. So this one is down now. If we are going back to the application, so if we for bank see the service chaining, we see two things. You see it. That Ola is down, and it kind of gets this fallback right away. It's like, okay, it's no point. I cannot go through this service chain. Somewhere in between, it's broken. And if you're going then to the historic dashboard, if we kind of do this a few times, we should see that the circuit for this service is open, indicating, here we go. You see, it's red, it's saying here something, and it should actually, you have to hit it. There's a kind of a count, basically, how often it has not to respond before then the circuit really. It should switch to red. The delays, I don't know why the delay is here so big. Leave it at that. Coming back to the pattern, and then the last pattern I want to mention is rate limiting. Rate limiting I don't hear so often, but I think it's a great technique. There, at rate limiting, the idea is that you put something at the entry point to your services, which allows you to rate limit. Now, per default, it can be just open, but it could also be that you want to slow down your services, that you can only do a certain amount of requests per second. So this way you can, if you have problems internally, you could, for example, like to the outward side say, okay, I rate limit a little bit to that, give my cluster or my application a little bit a chance to recover. It can also like do like things like from business point of view, if you have a rate limiting built into your system, where you can have different levels of like, if you are kind of platinum level, you can make as many requests as you want. But if you're like in the free tier, you have like like a GitHub API, you can make X amount of requests per time frame. So that's another pattern maybe to think about. Cool. We covered that. We covered patterns. We've seen a little bit how easy, like how OpenShift, like how containers are run there. What I want to show you now is this. Remember that part of the microservices was this automated pipeline. That was one key prerequisite, that I'm able to get my application in an automated way into production. And there's something really great in OpenShift. It's called a build pipeline, and that's what I want to show you. And I can do this with an example. So what we're seeing here, this is, yeah, doesn't really matter so much. So this is Aloha service. It's in Java. I think that's the Wildfly Swarm or Wildfly Swarm, I think, no, Vertex. It doesn't really matter so much. So let me find the right point. Aloha might have. So what I want to show you is, like, I'm a developer, I have this code checked out on my system, I kind of develop with it. Maybe I'm using Minishift, can test my whole microservice architecture locally, and I'm call now Aloha May Voxxed 2017, something like this. Save. I go to my console, git status. So you can see I have modified the file. Git add, git commit, -m, change treating, git push, my origin head. So what I've done as developer now, like, and it's like, you know, there are many kind of ways of a setup, but assume, what? Oh, it is my fork, sorry. I was pushing to the wrong repository. And I have to force push it, okay. All happening. So say this, I'm as a developer, I'm like now in a decision, okay, I'm good, I'm kind of made the changes requested for the feature, and I push to a certain location. Now I can go web console to OpenShift, and there's a concept kind of a build pipeline which is driven by Jenkins. So like OpenShift kind of starts a Jenkins instance in the cloud. It's transparent. Once you're using build pipelines, the Jenkins instance is started for you. If you want to see like what you need in your project is a Jenkins file which is then automatically picked up. And the Jenkins file is some sort of DSL written in Groovy, which kind of defines the stages, which is not, you have full control what this type of stages do. So in this case, it's like check out the repository, build it, maybe start it, so because that takes a little while. So here you see the pipeline, you see the source repository it's going to build, and you're basically just saying, okay, start this pipeline. And now you see like SCM checkout, do the Maven build, do the image build, do the automated tests, push the image into a staging environment where it can go maybe through additional QA testing, and then wait for approval. That will be a manual step. Like it sits there, the build sits there, with QA is happy with everything, and there's a manual step saying, now I'm ready, put this into production. So I hope we can also in the meantime go to Jenkins, so like log in with OpenShift. So this integration comes basically with OpenShift, so you kind of don't have to worry about kind of setting all these kind of things up. As you see, like here, you see then the build as it actually happens, and it kind of goes through these pipeline steps. And in the meantime, we can go back here, and as you see, it's like this DSL, and it has like build app, and it has promote image, it has Canary Deploy, and these are kind of abstractions you can build yourself. So if it's, as I say, it's a DSL. So let me find here. You probably cannot read that. So here is like build app defined, and what you're seeing here, it uses OC. OC is this command line tool I have been talking about to interact. So OC new build, that kind of triggers a new build, for example. Deploy app will kind of do OC new app, OC expose. I mean, these are kind of internal commands of OC of how to control the cluster or like the applications. So and you know, excellent. So like I have 5 minutes, so I probably can get through everything. As you can see here, it went through the pipeline. So we know the source code compiles, so the source code passes my unit test, the source code passes some automated tests, and now it kind of QA promote image. What that means is there is actually an environment in OpenShift, a QA environment, And that's also nice. In OpenShift, we have one bit OpenShift cluster, and we partition it. Like, here's the development area, here's the staging area, here's the production area. So it's one big cluster, but depending on how it is labeled, that's how it's done in Kubernetes, it's different kind of environments. So if you see here, and the endpoint is API Aloha. So you see, this new service in the staging environment is not live yet. So if I go back to my live instance, no, it's here. You see, this one is still the old application. Nothing has changed here. But for QA, for the people testing this kind of thing, they can already see this new microservice. They can test it. They can kind of let other people onto it. It's all good. Once, if you're going back to the build pipeline, where did we leave the build pipeline? Here, maybe? No. Yeah, QA. If you're going back to the pipeline in the CI environment, so here it says input required. So I click here. It kind of goes to this Jenkins build. Everything has happened now. People are happy with it. And I go like, proceed. And now comes the step which is kind of promoting the same, and that's also like, we built one container, one image, and we put it into the OpenShift registry, and it's this image which kind of gets unit tested, it gets tested in staging, and in the end it kind of gets promoted into production. We're not rebuilding anything, it's all, we are 100% sure we tested the very same thing we tested, made it into production. Finished success. So if we are going back now to the microservice and refresh, we should see that it says Aloha my Voxxed 2017. And this is where you want to end up in microservices. This kind of automated tool chain. Then you kind of get, like, if you have this kind of infrastructure, you go like, okay, I can control this thing, I can manage this thing without things falling apart and no one knowing where to look and what to do. I think that's my main takeaway here. You need to end up in a situation where you fully control your environment. And things like OpenShift can help you doing that. Build pipeline. Right. So one more thing, which is also nice. The last part of the thing. You might have seen that it says it in the last stage of the pipeline. It says it does a Canary Deploy. Everyone know what a Canary Deploy is? Quickly here. A Canary Deploy is, instead of like you have two replicas of the application, like there's a router and you have two instances of this application clustered, and you end up on one of them. A Canary Deploy is, instead of replacing both of these instances at one go and everyone gets this new application, you go like, nay, I want to see how things happen. And you set, the new application just gets added, and like in this case, basically, a third of the traffic goes to this new application. If you have your monitoring in place, you can then kind of look at the logs or like at the metrics of whatever you have to look at of this third application of the Canary to go like, is this better? Do people stay longer on my site now with this thing? And if so, then you can scale up the Canary application and you can take down the others. I can hopefully, last thing, I can hopefully show you that if I go this. Yeah, you mean this data and database? Yeah. I mean, it all falls down once you have a database. Like, as long as the data is stable, no problem. Once you have to data migration, then it gets tricky. Sure. I mean, but this problem you have to solve with or without. Aloha curl. Hopefully it works. So what we should see now. So here we see it. I did this Canary deploy. So 50% of my requests go to the original, and 50% goes to this Canary. So if we are going back to, and I can show you this in the console. Many tabs to manage, sorry. So if you refresh, here we go. Here you see, here is Aloha, and here is the second Aloha. That's the Canary. And now I can kind of investigate, and obviously you need the metrics. It doesn't help you to do Canary Deploy if you cannot draw a conclusion out of it. You have to put some metrics, and you have to know in beforehand, what do I look for? What I'm looking for, is it in the log files? Do I have to do something else? But if you have this, you can kind of monitor now. You can go, okay, this application is better. I shut this one down and kind of scale this one up to whatever I need. So this is this Canary deployment. And again, with OpenShift, super easy to do. Yeah, let me go back to my slides. I think time is out anyway. Well, thank you very much. I cannot stop without a nice, cute picture of a cat. If you want to reach me, if you have any questions, email hardyferentschik@redhat.com, Twitter, GitHub. Just send me a message. I'm happy to respond. And I'm not sure, can we take any questions? Or so if you have any questions, yeah?
In case you have in case you deploy a microservices, and then you have 10, many of them, 55, 155, as many.
Yeah.
And then you have a monitor system and everything. And then one day you deploy a new release, and after some time, after 2 days, the monitor will bring back everything read from 55 or from half of the services. I mean, how do you troubleshoot? Because it's not going, there are cases when the metrics or the monitor system will say only one service has a problem. Then you go and troubleshoot that. But what happens when you have one source that it will produce many errors from other services?
Yeah, I see what you're saying.
And then you get 10, 25 services with errors. How can
Right. You're basically saying something fails, and because of this thing failing, other things will start failing too, and then you get a whole explosion of errors. Yeah, I mean, things are not getting easier. I mean, you have to understand your application, and at that stage, DevOps comes into here. Like, if you have teams which are built from development into production, these people know a lot about the software, how it's written. And these, like, if you write the software, you also kind of have a feeling of this happens, and you're able to determine, I ignore this, that's kind of follow-up errors, this is my root. But someone, as you say, like, someone has to know, okay, this is a root. And in the worst case, you have to sift through everything, but if you're good, you go like, yeah, no worries, it's this one, and you kind of focus your attention there, and you basically know everything else are follow-up issues. But it's, you know.
Okay, and then where these things stops? I mean, when you break down, when you are designing and you break down what you are making a separate microservice, is it going down to single functions? Is it some modules? I mean, where this ends?
As I said, this is cutting edge. I think people try to find a standard here yet. And I think it's hard to say it's 500. It's not easy to say it's based on lines like 500,000, 2,000 lines. I think it's a case by case. It depends. You always have to look at the application, what makes sense, what doesn't make sense. And it should be around your business capabilities. It's hard to kind of pin that to a concrete size in lines of code. These kind of things, it works like some people, for example, say, build the monolith first. Build the single application and start breaking things out, which is sometimes easier to, some say it could be easier than trying to go microservices right out. And you know, this OpenShift is great for monolith as well. You can deploy your Java EE application on OpenShift without any problem. So it depends. It kind of, you know, you have to look at this with a good sense of, with common sense, basically. Okay, yeah?
You must implement a rate limit. If you have a problem to the cluster to come up, the rate limit must be implemented by the service or provided by the infrastructure.
When we're talking about rate limit?
Rate limit to the microservice, to the request, how to respond to the request.
How to do it, or?
No, it must be implemented by a service that I wrote, or offered by infrastructure by OpenShift?
Yeah, so there are tools which kind of offer it as a kind of a framework. There's one company we work with which is kind of all about kind of putting, what's it called, scales, which is all about kind of putting REST calls and stuff or APIs behind this kind of rate limiting and authentication things. The alternative is, yeah, you kind of build it yourself as part of each single service or as part of the gateway maybe. It's actually there are quite simple algorithms if you want to do yourself. It's called a bucket algorithm basically. A request comes in, you see if you have enough tokens in the bucket. If yes, you can kind of let it proceed. If the bucket is empty, this thing has to wait until the token as a bucket refresh. There's quite simple algorithms to implement it yourself. But I think what you're talking about is like tools which kind of do it for you. Scales, I can't remember. Sorry. One final question maybe? Yeah?
So I was wondering, since OpenShift is technically a Kubernetes, more or less.
It is.
Apart from it being cloud-hosted or a software as a service solution, what's there on top of it comparing to Kubernetes? Actually, namely, what I'm interested in is, does it offer any out-of-the-box solution for A/B deployments like VAMP and something like overall description for the deployments like Helm?
VAMP is for you?
VAMP is the name of the framework which does A/B testing on top of Kubernetes. A/B deployments actually.
Doesn't ring a bell. So the big difference between Kubernetes, like this idea around project and namespaces users, that's kind of quite new. There's also in OpenShift the concept of a route, so you can take your service and expose it to the outside world via a route so that people can access it. That's also not directly part of Kubernetes. So there's these kind of things which are additional on top of Kubernetes. And then obviously for Red Hat, when you have the enterprise Red Hat, like OCP it's called, OpenShift Container Platform, the key thing is that your base images are based on Red Hat, so you get the RHEL kind of core images. But in the end, for me, like OpenShift is like it's basically Cube. So if you're happy with Cube, OpenShift can give you a little bit extra. There's also OpenShift Online, which is basically a Red Hat provided hosted version of OpenShift you can start with. There's a free tier, which doesn't give you so much, but for $50 a month or something, you get a decent OpenShift environment which you can try and work with. And then obviously if you need more, you have to decide, is it better to go to another cloud provider, or should I run internally or something? Okay, I think time is up.
Our time is up. Thank you very much.
Thank you.